Hello, and congratulations, you survived the addition, subtraction of rational expressions. Like I said, nothing new, but just a lot of tedious work along the way. Okay, so now we're going into multiplying and dividing rationals. This is much easier. Basically, as long as you can factor, all we're going to do today is basically factor, cancel, non-permissible. So again, like I keep saying, nothing new, but that's to encourage you to say that we've been practicing these skills and now we're just using them. Okay, so again, like I don't really have notes to give to you because if you know how to multiply and divide fractions, then you also know how to multiply and divide rationals. So let's just go back and do a quick review. So if we have A over B times C over D, the rule is you multiply across and the numerator and denominator. So it'd be AC over BD. We did have those on mental math, and I know that some of you were still struggling with multiplying fractions then, so you've had a few months to get that sorted out. So multiplication is easy. You multiply across for both the numerator and denominator. But if we divide A over B divided by C over D, remember to divide a fraction by a fraction, you multiply by the reciprocal of the divisor. So in that case, now we multiply, so it's AD over BC. I'm ignoring non-permissibles for now, but just reminding you the basic rules of how you multiply and divide fractions. Okay, so we are ready to go to our examples. Oh, just a reminder that before you go to multiply, you should always factor and then simplify. So like I said, whole bunch of factoring today. So if you can factor, really easy, just factor, cancel, non-permissibles. Okay, here we go. So our first example, x squared plus 2x minus 8 over x squared plus 3x, and we're multiplying that by x squared minus 9 over x plus 4. Step number one, factor. So the factored form here, this would be an x plus 4 and an x minus 2. Again, the denominator, you're factoring out a common factor of an x. This side, x squared minus 9, difference of squares, so an x minus 3, x plus 3, and x plus 4 is just x plus 4, and that's a bracket. Okay, so step one, factor, easy for us. Now here's the new part, because we're multiplying across, you would just multiply across the numerator and denominator. But to make life easier, we can simplify a bit. We have an x plus 3 here, an x plus 3 here. They can cancel, but they're in two different terms. Can we do that? Sure we can. As long as you have one on the bottom, one on the top, doesn't matter if they're in the same term across. Because you're multiplying, we're allowed to do that. So the x plus 3's cancel out. Does anything cancel out? Yeah, we have an x plus 4 cancels out with the x plus 4. And nothing else cancels out. So the final answer, we were left with an x minus 2, x minus 3 in the numerator, and all we're left with is an x in the denominator. Now the only thing left is the non-permissible. We did talk about this last lesson. Where does the non-permissible come from? Here, where it's already simplified, or here it's been factored? You have to take the non-permissibles before you simplified. So once it's factored and before it's simplified. You technically can get it from here, but that's really hard to see. So the best line is once it's factored before it's canceled. And again, we're just looking at the denominator. We don't care about the numerators, not for non-permissibles. So when an x is by itself, here x cannot equal 0. From this term here, x cannot equal negative 3. Then we have to look at this part as well. From this denominator, x cannot equal negative 4. So you have three non-permissibles. You have to look at all the spots where you have a denominator and take it. We don't use a numerator. Numerator can be 0, just not denominator. Okay, so that's kind of the basic idea. Let's try one more. Let's try a division question. Okay, x squared minus 81, difference of squares. That's an x minus 9, x plus 9. Now, I'm going to do some rough work off to the side. 2x squared minus 50. That's a fun one. So this is my rough work here. If I factor out a 2, I'm left with 2x squared minus 25. So there's a double factoring. First, you have a common factor, and then when you take away the common factor, you have a difference of squares. So I'll do two steps in one to save video time and board space. X squared minus 25 is a difference of squares. That's an x minus 5, x plus 5. So watch out for that double factoring. You have to factor as much as you can. Okay, now here's the fun part. It's a division. So I change it to multiplication, and then I'm going to, I guess for sake, you can skip this step, but since we're not together, I just want to be clear that you multiply by the reciprocal of the divisor. So this one stays the same, change the multiplication, you flip it around. So I'll rewrite the part that we've already done. That's already been factored. Now I can factor this. Remember, I had to flip it around. This is x plus 5 times another x plus 5, and the denominator, common factor, so that is the factored form. Okay, now hopefully some things cancel out. So we look, what cancels out? We have an x minus 9, cancels out that x minus 9. This x plus 5, it cancels out one of the x plus 5s, not both of them, right? You can only cancel one factor out at a time, and I believe that's it. I don't think there's anything else that's in common. I'll switch to another color just so you can see what we're left with. So we're left with an x plus 9 here and an x plus 5 here. Oh, we have a 2 and a 3, which is 6, so you should clean up a bit. And we're left with an x minus 5. Oh, and that's it. So that is what we are left with. And again, there's no need to multiply out the numerator. Once it's factored, simplified, that's it. The only thing we do need to do is get our non-permissibles. Okay, now here's the fun part. Where do we take it? We already said we take it from this step. When it's already been simplified, or when before it's already been factored but not simplified. But here's the fun part. Where's our denominator? Well, this is easy. This was our denominator. Well, I want it to be a different color. This was always denominator. But what do we use here? Because remember, this is our denominator now, but initially that was our denominator. Remember, we flipped it around? So this was the denominator initially, and then this became. So which one do we use? We have to use both, because at some point each one of them was a denominator. So you just take the denominator here, but you take from both parts because remember we flipped it around. So you take it from 3 out of the 4. Basically the only spot you don't take it from is that initial numerator. Okay, so let's check this out. So here our non-permissible would have been a plus 5. From here it would have been a negative 5. If we look up here, it was a negative 5. I already have a negative 5. Do I have to write it again? No, once I have it once, it's already accounted for, so I don't have to include it. And then I have a plus 9. So those are my non-permissibles. So that's just a little thing for when you divide. Remember, you actually have 3 spots. So whatever you need to check, or whatever you need to do to remind yourself, you've got 3 spots to check instead of 2. 3 spots for dividing, only 2 for multiplying. Okay, we've covered one of each, so let's just try one more of each, just practice. I think you've got all the steps down. So for this example, well, the nice part is there's nothing here to factor. Okay, well, that's easy. Oh, factoring where a is not 1. I know you guys have a hang of that. I know it's a little bit tough still in grade 11, but keep practicing and you will get it. If you do it correctly, it's a 2x minus 1, 2x minus 1, and that is 4. Okay, step 1, we multiply. Does anything cancel? Yep. This 2x minus 1 cancels that out. It doesn't cancel both. Remember, you can only cancel one factor out at a time. So what we are left with, we have an x minus 2 times a 2x minus 1 all over 4. So that is our final. Now, what's our non-permissible? Well, there's 2 spots. Remember, we take it from this step. Once it's factored before we simplified. Here, 2x minus 1. X cannot equal 1/2. Oh, what's the non-permissible here? 4? 4 is just 4. There's no variable, so there's no non-permissible. That will always be 4. So you only have one non-permissible. X cannot equal 1/2. And let's do one final one, another division one. Now this is easy. There's no factoring to be done, but I find this one sometimes gives students the hardest. They struggle with this one most. They do better. Once you get the hang of factoring, factor cancel pretty easy. This one actually takes us back to grade 10 math with our exponent rule. So let's try this one. It is a division question. There's nothing to factor. So remember, I changed to multiplication. You multiply, you multiply by the reciprocal of the divisor. Now, you could simplify first and then multiply. That's the way I would do it. But because we're not actually in class together, I'll just multiply them first, then simplify. But like I said, if you want to simplify first, by all means, go ahead. So 2 times 10 is 20. 5 times 8 is 40. And now we do have to simplify. So 20 over 40 simplifies to 1/2. Now again, there's no factoring, but these are our grade 10 rules. X squared divided by x. Basically, this x cancels out 1, so you're left with just an x on top. And then the y's, you have 1 y on the top, 3 in the bottom. That cancels out to leave you x squared. That's a little bit tough to see, so it is 1x over 2y squared. And again, our non-permissibles. We have no non-permissibles here. Remember, we have to look at both spots. There's no variables, so x cannot equal 0 and y cannot equal 0. So it doesn't always involve factoring. Sometimes you're just multiplying and then just simplifying using our exponent rules from grade 10. Okay, again, I'll give you a couple days to work on this assignment to give you lots of time to practice. We're almost done the unit. The only thing we have left now is solving rational equations, which we'll look at next week. So good luck and have fun.